Welcome to Balaya Math Lectures. Learn every step. Today we will discuss how to find the solution of a system of linear equations. You have two types of linear equations, so-called homogeneous system of linear equations and a non-homogeneous system of linear equations. Let me give you some examples to understand what is system of homogeneous equations and what is system of non-homogeneous equations. Suppose if you have the equations 2x plus 3y is equal to 0 and 3x minus 2y is equal to 0. The equations are equal to 0. Such equations are called homogeneous system of equations. If these two are non-zeros, at least one is non-zero, then this system is called non-homogeneous system. Now, first of all, let me give you the linear equation. Suppose I am considering that 3x minus 3 is equal to 0. From this, it is easy to understand that if you put x is equal to 1, then 3 into 1 minus 3 is equal to 0. So called solution of the equation. This is solution of the equation or 0 of the equation or root of the equation. These three names are same for the solution of the equation. Here x is equal to 1 is the solution for this equation, and also you can notice that the degree of x is 1. Okay, that means the powers of the variables must be 1. Such type of equations are called linear equations. Now you can easily notice that there is no other solution except 0. That means if you put x equal to 0 and y equal to 0, your equations are satisfied. It is so called trivial solution. When x equal to 0, y equal to 0 is the solution, it is called trivial solution of the homogeneous system. Now you can notice two more equations I am giving you here. 2x plus 3y is equal to 0 and 4x plus 6y is equal to 0. Without sense, you can understand that if you put x is equal to minus 3 and y is equal to 2, this equation will be satisfied. If you put x is equal to minus 3 and y is equal to 2, minus 3 into 2, minus 6 plus 3 into 2 plus 6. 6 minus 6 is equal to 0. Of course, this equation also satisfied by these two values. And you can observe that x equal to 0 and y equal to 0 is also the solution for this system. If you put x equal to 0 and y equal to 0, this equation is satisfied. Of course, this one also. X equal to 0, y equal to 0 is also the solution for this equation. So that 0 solution is always called the trivial solution of the given system of homogeneous equations. Now you can notice that minus 3 comma 2 is also solution for these two equations, and also observe x equal to minus 6, y is equal to 4. Minus 6 into 2, minus 12, 3 4s are plus 12. Minus 12 plus 12 is equal to 0, and 4 into minus 6, minus 24. 6 into 4 plus 24. 24 minus 24 is equal to 0. That means this is also one more solution. And also you can observe that x equal to minus 9, y is equal to 6. X equal to minus 3k and y is equal to 2k are the solutions for these two system of equations. That means if you put k is equal to 1, it is a solution. K is equal to 2, it is also a solution. K is equal to 3, it is also a solution. That means the system will have infinitely many solutions. These are called non-trivial solutions because these are not equal to 0. When x equal to 0, y equal to 0, it is a trivial solution. Except 0 solution, if the system has a solution, that is called non-trivial solution. If the number of equations and the number of variables are increased, it is tedious to find such solutions. So that the concept of matrices are introduced to find such non-trivial solutions. Let us understand how to find the non-trivial solutions for the homogeneous system of equations. Now, let us discuss the homogeneous system of linear equations. The m linear equations with n unknowns are considered. Those are a11x1 plus a12x2 plus on up to plus a1nxn is equal to 0. a21x1 plus a22x2 plus on up to plus a2nxn is equal to 0 and up to am1x1 plus am2x2 plus on up to plus amnxn is equal to 0. This is called homogeneous system of linear equations. These can be written in matrix form. The matrix form of the system of homogeneous equations are a11, a12, so on a1n, a21, a22, so on a2n, up to am1, am2, so on amn, into x1, x2, so on xn is equal to 0, 0 up to 0. And you can observe that the order of this matrix is m by n and the order of this matrix is n by 1 because you have n rows and 1 column, and this will have m equations and only 1 column, so that the order of this matrix is m by 1. This can be written as Ax is equal to 0. Here your A is called the coefficient matrix, X is called the matrix of unknowns, and 0 is your 0 matrix. To solve such type of equations, you have to reduce this matrix A to echelon form. After reducing this one into echelon form, you can find the rank of the matrix A, let us say R. And you can observe the number of unknowns from the unknown matrix is n. Actually, you have n unknowns here, that's why I am considering n unknowns. If the rank of the matrix is equal to the number of unknowns, then the system has 0 solution or trivial solution. This is first case. If R is equal to n, the system has 0 solution or trivial solution. If rank is less than number of unknowns, the system has infinitely many solutions, which you have already discussed in your previous example. So, if R less than n, the system has infinite number of solutions. The system has infinite number of solutions and n minus R linearly independent solutions. Here you got the doubt that what is linearly independent. If suppose you have n vectors, then we have to take the linear combination of those n vectors which are equal to 0, and if you notice that the constants in the linear combinations are all 0, then you can say that the n vectors are linearly independent. Let me give you an example here, what I am explaining in words. If you are considering the 3 vectors v1, v2, v3. Now let us take the linear combination of these vectors. Say a1 v1 plus a2 v2 plus a3 v3 is equal to 0. This is called a linear combination. If this linear combination is equal to 0, and upon solving you can get the values of a1, a2, a3 as 0. That means a1 equal to 0, a2 equal to 0 and a3 is also 0. You can say that these 3 vectors v1, v2, v3 are linearly independent. Let me give you one example here. Suppose a1 into 1, 0, 0 plus a2 into 0, minus 2, 0 plus a3 into 0, 0, 3 equal to 0, 0, 0. That means I am taking 3 vectors and consider the linear combination of these 3 vectors by multiplying the constants with a1, a2, a3 and equal to 0. You can notice that a1 into 1, a1 plus a2 into 0, 0 plus a3 into 0. 0. A1 is equal to 0 directly. And A1 into 0 is 0. Minus 2A2 plus 0. Minus 2A2 equal to 0. That means A2 is also 0. Similarly, you can observe that A3 is also 0. From this calculation, you notice that the linear combination of these three vectors are equal to 0. All the constants are 0. So that these three vectors are called linearly independent. If any one scalar is non-zero, then you can say that these are not linearly independent, which means they are linearly dependent. Let us solve some examples for finding of trivial solution and non-trivial solution. To solve the homogeneous system of equations, here you have to note 2 points. First, if suppose your Ax is equal to 0 is the given homogeneous system of equations, when will you say that this is having infinitely many solutions? When will have this is having trivial solution? Suppose that A is a square matrix of order n and X is the unknown matrix with number of unknowns n, and if the rank of this matrix is n, which will be the number of unknowns, that means the system will have trivial solution. And how can you say that this is having rank n? If you reduce this one into echelon form, you can find its rank, but there is another way you can say that its rank is n. If the determinant of this matrix is not equal to 0, if det A not equal to 0, that means non-singular, the system has trivial solution. If suppose det A is equal to 0, the rank of the matrix is less than n and the number of unknowns are n. So r less than n, the system has infinitely many solutions. If A is non-singular, the system has trivial solution. Then Ax equal to 0 has trivial solution. If A is singular, that means your det A is equal to 0, then Ax equal to 0 has non-trivial solution. I think you got the point that when will the system has a trivial solution and non-trivial solution. If A is non-singular, then Ax equal to 0 has trivial solution. If A is singular, then Ax equal to 0 has non-trivial solution. Here you can easily notice that non-singular trivial solution, singular non-trivial solution, opposite. You can easily remember when the system has a trivial solution and when the system has non-trivial solution. Now let us solve the given system of homogeneous equations. Here are the equations: x plus 2y plus 3z equal to 0, 3x plus 4y plus 4z equal to 0, 7x plus 10y plus 12z equal to 0. Now I am writing the matrix form of the given system of equations directly. The matrix form of the given system of equations are 1, 2, 3, 3, 4, 4, 7, 10, 12 into x, y, z equal to 0, 0, 0. This is of the form Ax equal to 0. Now you have to reduce this one into echelon form, so that I am using this element and make these two elements as 0. That means R2 tends to R2 minus 3R1, R3 tends to R3 minus 7R1. If you do so, the matrix will be reduced to no change in the first row, 1, 2, 3. 3 minus 3, 0. 4 minus 6, minus 2. 4 minus 9, minus 5. And 7 minus 7, 0. 10 minus 14, minus 4. 12 minus 21, minus 9. X, Y, Z equal to 0, 0. Now use this element and make this one as 0. R3 tends to R3 minus 2R2. If you apply, then no change in first two rows, 0, minus 2, minus 5, 0. Our target is 0 because you have to multiply this one with 2 and subtract from this one. 4 minus 4 plus 4 equal to 0. Minus 9, 5 2s are 10, 10. 10 minus 9, 1. Into x, y, z equal to 0, 0, 0. What you have observed, this is in echelon form, and the rank of this matrix is the number of non-zero rows which are 3. Therefore, rank of A is equal to 3. But also the number of unknowns which are 3 here. When rank is the number of unknowns, the system has trivial solution. That means your capital X equal to 0, 0, 0. Your x value is 0, y value is 0, and z value is also 0. Let us solve one more problem to find the non-trivial solution of homogeneous system of linear equations. Let us solve this problem. Now I am writing the matrix form of the given system of equations directly and coming to the solution. The matrix form of the given system of equations is 2, 1, 0, 1 and 4, 2, 1, 3, 6, 3, 4, 7 into x, y, z, w is equal to 0, 0, 0. Now you have to reduce this one into echelon form is our procedure. So use this element and make these two elements as 0. That means R2 tends to R2 minus 2R1. R3 tends to R3 minus 3R1. So if you do so, no change in the first row. 2, 1, 0, 1. 4 minus 4, 0. 2 minus 2, 0. 1 minus 0, 1. 3 minus 2, 1. 6 minus 6, 0. 3 minus 3, 0. 4 minus 0, 4. 7 minus 3, 4. X, Y, Z, W equal to 0, 0, 0. Now use this element and make this one as 0. That means R3 tends to R3 minus 4 R2. 2, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0 into X, Y, Z, W equal to 0, 0, 0. What you have noticed? The number of non-zero rows are 2, but number of unknowns are 4. That means rank less than number of unknowns. The system has infinitely many solutions and n minus are linearly independent solutions. Therefore, rank of A is equal to 2 less than 4 is equal to n. Here rank is 2, number of unknowns are 4. Rank clearly less than number of unknowns. That is, the system has infinite number of solutions. Infinite number of solutions. And n minus r, which is 4 minus 2 is equal to 2 linearly independent solutions. Now you need to find those 2 linearly independent solutions. For that, let us write the equations. That means 2x plus y plus w is equal to 0 and z plus w is equal to 0. Here you need to take 2 variables as constants because your linearly independent solutions are 2. So that we have to assign 2 constants to 2 variables. So that I am considering y as k1 and w as k2. Then you can find the values of all x, y, z and w. Y is equal to k1 and w is equal to k2. Then your z is equal to minus w, that means minus k2. Now you know the values of y, z and w. You can substitute in this equation to find the value of x. That means 2x is equal to minus y minus w. Minus y is minus k1, minus w means minus k2. And take 2 to the other side, that implies your x is minus 1 by 2 into k1 plus k2. Therefore, your x is something into k1 plus something into k2. That something can be found as the coefficients of k1 and k2 from x, y, z and w. Okay, from this one, your x value is minus 1 by 2 into k1. So k1 coefficient is minus 1 by 2. And y, k1 coefficient is 1. And in z, there is no k1, which means 0. And w, there is no k1, which means 0 again. And also, the coefficients of k2 can be observed from x, y, z and w. So, in x, the coefficient of k2 is minus 1 by 2. And in y, there is no k2, 0. And in z, there is k2, which is minus 1. Its coefficient is, and w, 1. So, these two are your required linearly independent solutions. That means if you equate this linear combination to 0, your k1 value and k2 value will be 0. This is the way how to find non-trivial solution of the given system of. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.